is called a Fibonacci number, Leetcode 509. So a Fibonacci number is actually like a sequence that is calculated as follows. It starts with a 0. The first number of Fibonacci sequence, let's say let's say it's 0 based. In this case, it's showing you like f of 0, right? So if we run this function, we pass a 0, it should return a 0 because the 0 value, or the first one, is 0. The second Fibonacci number is 1, so that's a given. Okay, so that's why they're telling you here. And the way it works is that any consecutive number is the sum of the previous two. So f of 2, 0, 1, 2, is actually 1 actually, because you sum up the previous two. And then the next one is actually 2 because you sum the previous two. And then the next one will be 3, 5, 8, 13, and so on, right? Because this guy is actually the sum of the previous two. This one is the previous two, and so on, right? So the easiest way to solve this problem is through recursion. So basically, we are calling the function itself with a subproblem, right? So let me just write down the solution. It's only just a few lines of code. So so the first thing we need to check is the sort of the base case, which is here, because what happened is that you will supply an n, and then we're gonna call this function with smaller numbers, so that it will eventually reduce to 0 or 1. So let's say if n is equals to 10, right? Meaning that you want to see 10 Fibonacci numbers. Then you want to call this function. Actually, they even provide a formula for you here. So if you are calling with 10, then basically you want the results of the previous one, 9, and plus the result of the 8, Fibonacci of 8, and so on, right? So eventually you go down to 0 and 1, which terminates the recursion. So so you check here, right? If n, right, is less than or equals to 1, right, then just return n, right? So that we don't have to have two conditions. So when it's 0, returns 0. When it's 1, returns 1, right? So this is this condition. If that is not true, that means f is like 3 or 4 or 5, right? Then basically you want to call, well, you want to return, because it's a function, right? You want to return the Fibonacci sequence, the same. You call the same function with a different n. In fact, you want to call it with n minus 1, which is in the example here would be Fibonacci of 9 plus the Fibonacci number of n minus 2, which is 8, right? And that's it. Okay, so let me just delete this number here and run this program right here. Accept it, right? Okay, and it took 67 milliseconds. We can actually optimize this solution, because what's happening here is that when you call 10, right, it then calls 9, okay, and 8, right? And in turn, 9 calls 8 and 7, right? Right? And so on, right? And then, so you can see here, this 9 calls 8, and then this 10 also calls 8, right? So there's some repetition here, right? So you don't want to actually use a recursion when you already have the results here, right? So one way to optimize this is to use a technique called memoization, which basically means that we're going to store, so we intercept this value here, right? And we put them in a map, a hash map, right? And so before we call this function next time, we check if this n is been used before. So the map will actually store the value of n plus the result, right? So if it's already found in the map, then we just return it from the map. We just get the value from the map, as opposed to call recursively these two numbers again, and that will actually makes the performance much better. So let's declare a hash map outside this function. So let's say map is equals to new map rate. Okay, and so here we're going to check, right, if map has n, okay, then we just return, right, map.get n. Okay, so basically what this is saying is that if it's in the map, then instead of calling this return, we just going to just return this value because we already know. Okay, so this function, this serves as an else here, right? Because after the return, we're done. So before we return the values here, we should store them in some temporary variable. So let's say let temp equals to, right? So if it's not in the map, then we calculate it, right, the normal way as we did before, and then we put them in the map, right? So mat dot add, yeah, temp, right? So we add it to the map. No, the set, right? So so this tells you for the given n, right? Because in this function we're calculating n, right? So for this n, the answer is actually this temp, right? And now we can just return the temp. Okay, so if we were to run, let me just delete this one here. Run this one, you can see the runtime will be much less. You can see it's 44 milliseconds. And if you can run it again, just make sure that it's not a fluke here. 58. You can see it's about maybe 20-30% faster. Thank you very much.